Dear professional students, let's look at what we mean by null hypothesis. When we are talking of null hypothesis is the hypothesis formulated with the purpose of rejecting it. That is one thing I need to let you know. And the other thing is that null hypothesis states that there is no relationship between two population parameters, that is, between independent variables and dependent variable. If hypothesis shows a relationship between the two parameters, the outcome could be due to an experimental or sampling error. However, if null hypothesis returns false, it means that there is a relationship between the measured phenomenon. So, null hypothesis is useful because it can be tested to conclude whether or not there is a relationship between two measured phenomena. It can inform the user whether the results obtained are due to chance or manipulating phenomenon. Testing a hypothesis sets the stage for rejecting or accepting a hypothesis within a certain confidence level. There are two approaches to statistical inference in null hypothesis which can be used. We have significance testing and we have hypothesis testing. We have significance testing and hypothesis testing. These are the two testing under null hypothesis. So, if the null hypothesis is rejected, let's talk when we're talking about significance testing. Under significance testing, this approach states that a null hypothesis is rejected if the measured data is significantly unlikely to have occurred. That is when null hypothesis is false. I said when if it is significantly unlikely to have occurred, when the assumption you have made to have occurred, that is when your null hypothesis is false. And before I even go further, I need to let you know what by hypothesis itself. Hypothesis is an academic guess or assumption that is used to reduce the research problem to a testable format. So that's one hypothesis. And the first assumption, one of the assumptions could be null hypothesis. That is, hypothesis that says there is no relationship between the variables in the research topics. And we said this null hypothesis could be tested in two ways. We have significance testing and we have hypothesis testing. And under significance testing approach, what it says is that a null hypothesis is rejected if measured data is significantly unlikely to occur. That's the one. That is, the hypothesis you have formulated is false. Therefore, the null hypothesis is rejected and replaced with alternative hypothesis. If we observe outcomes is consistent with the position held by the null hypothesis, that is, if after the testing what you observe is synonymous with your position in the null hypothesis, then the hypothesis is accepted. That's the hypothesis will be accepted. And on the other hand, the hypothesis testing, which is the second type of testing we say here, according to Neiman and Passing, is compared to the alternative hypothesis to make a conclusion about observed data. So the two hypotheses are differentiated based on the observed data. Now, let's look at this to summarize what we just said. The first thing is that hypothesis refer to hypothesis that state that there is no relationship between the two population parameters. That is one. 2. Researcher reject or disprove the null hypothesis to set stage for further experimentation or research that explain the position of interest. And the third one is that the inference of a null hypothesis is an alternative hypothesis which states that there is statistical significance between two variables. So that's about null hypothesis. The other side we want to look at is how does it work? That is how the null hypothesis work. The null hypothesis is a theory based on insufficient evidence that require a further testing to prove whether the observed data is true or false. For example, a null hypothesis statement can be the rate of plant growth is not affected by sunlight, like example I gave the other time. Understand? So it can be tested by measuring the growth of the plant in presence of the sunlight and comparing it with the growth of the plant in the presence of or absence of sunlight. So rejecting the null hypothesis set a stage for further experimentation to see if there is a relationship between the two variables. And rejecting a null hypothesis does not necessarily mean the experiment did not produce the required result, but it set the stage for further experimentation. That's on that. And let's look at the example. Example of null hypothesis. The annual return of ABC limited bond is assumed to be 7.5%. Test if the scenario is true or false. So we take the hypothesis to be the mean of the annual return of ABC limited by bond is not what? Is not 7%. So to test the hypothesis, we first accept the null hypothesis that it is not 7.5%. So any information that is against the stated null hypothesis is taken to be alternative hypothesis. And for the purpose of testing the hypothesis, in such a case, the alternative hypothesis is the mean usual returns of ABC Limited, which is 7.5%. So we take the samples of the annual returns on the bond for the last 5 years to calculate the sample means of the previous 5 years. The results then compared to the assumed annual return average of 7.5% to test the null hypothesis. So the average of the annual return for 5 years is what? Is 7.5%. Then the null hypothesis is rejected. Consequently, the alternative hypothesis is accepted. This is how it is done. Null is usually written H naught and what? Alternative written HI. So null hypothesis will be the average annual return is not 7.5%, and the alternative is average annual return is 7.5%. So once our activities negate this, we accept this. Understand? So that's about the null hypothesis. And the other part, it is what? It is alternative hypothesis. What's an alternative hypothesis? An alternative hypothesis is an hypothesis in the inverse of the non-hypothesis. An alternative hypothesis and non-hypothesis are mutually exclusive. That is, both cannot be right at the same time, which means that the only one of the two can be true. So a statistical significance exists within the two variables. If samples used to test the null hypothesis return false, it means that the alternate hypothesis is true. And the alternative hypothesis is what we refer to as alternative hypothesis. So there is significant relationship between the two variables in question. What is the purpose of hypothesis testing? The purpose of what? Hypothesis testing. The purpose of hypothesis testing is that this concept, that is hypothesis testing, is a statistical process of testing an assumption regarding a phenomenon or population parameter. It is a critical part of the scientific method, which is a systematic approach to assessing theories through observations and determine the probability that a stated statement is true or false. A good theory is one that can make accurate predictions. For an analyst who makes predictions, hypothesis testing is a rigorous way of backing up his predictions with statistical analysis. So it also helps to determine if there is sufficient statistical evidence that favors a certain hypothesis about a population parameter. So that is about null and alternative hypothesis. I hope with this little we have actually tried our best. And we have types of alternative hypothesis. Type of what? Alternative hypothesis, which I denoted as HI. We have left-state alternative hypothesis. Here it is expected that the sample proportion is less than the specified value, which denotes that pi, it is denoted by what? By pi. I said left state is when it's expected that the sample proportion is less than the specified value. That is that, and it's in this format. We have HI, that is pi is less than pi naught. Understand? So specified value is denoted by H naught. So it means that our sample proportion, which is pi, is less than specified value. That's the left state. The right state represents that the sample proportion is greater than some value denoted by H naught. So some value which is H naught is less than this. That is, our sample proportion is greater than some value or specified value. We also have two-tailed, and according to this hypothesis, the sample proportion is not equal to specific value, which is represented by H naught. So this is a two-tailed value. It's not equal. It could be either less or more. And one thing to note is that the null hypothesis for all the three hypotheses is what? Is that the proportion value is equal to specified value. So that is about that, and we have come to the end of null and hypothesis value.